Hello, welcome to the New Stack Makers, a podcast where we talk about at-scale application development, deployment, and management. Packet enables developer-led companies to deploy physical infrastructure at global scale in under 60 seconds. With 18 plus public cloud locations, as well as private deployments and on-premises software solutions, Packet helps make infrastructure a competitive advantage. All right, we're here at IFX, and IFX has really come a long way, Zach, since
The
last
second annual.
The second annual. You know the rule is you can only say annual after the second, when you're doing the second one.
You can't say first annual.
Yeah, you can't say first annual. So it's officially an annual conference.
That's the thing.
I think I love this space far more than last year's, even though last year's was fun just because it was so new and so
So
fresh.
you like this parking lot better than
I like this parking lot better than the other one. I like the downtown Vegas kind of.
The downtown feel is pretty awesome.
Yeah, so we're here at IFX, and it's an event that Packet's hosting, and there's a number of sponsors that are participating. Zachary Smith, CEO of Packet, and we are joined by Ivo Rook, Senior Vice President at Sprint.
I'm here.
So I have a question for you, Ivo, and I found this on a podcast actually.
Okay.
You have a nickname, the Machine Whisperer.
That's correct, yes.
How did you
How do
get
I not
this
know
nickname?
about this?
Well, it's actually how you should get your nickname. It's actually, as you know, when you have kids, every now and then kids need to explain what their father or their mother does, right? And actually this whole name, the Machine Whisperer, came when my youngest, 7 years, at school had to explain why her father was always traveling, because my family lives in the Netherlands, and I live in the US, and I go back and forth all the time. And she had to explain to the teacher, why is daddy never there? And then she actually gave the answer, because my daddy is a machine whisperer. Seriously, I kid you not.
That's a great one.
And so my 7-year-old actually says that's what my father does. He talks to machines.
He talks to machines.
And he listens.
And
they listen.
Is this a literal translation from the Dutch, or is this?
No,
she gave it to you in English.
Well, actually, do you know that in it's probably UK series, but it was in the Netherlands as well. There were these animal whisperers and baby whisperers and so on. So she probably YouTube that or whatever, and she translated that to me to be the machine whisperer.
Well, I just saw that. And I just had to ask, and so I think the fact that you're in IoT then speaks to machine whispering in some respect. Where does bare metal fit into the IoT story these days? What is going on? And in that realm, and I want to bring back this metaphor of the whisperer, but I'm trying. I think I'm trying too hard. But I would love to get that connection.
Well, when you whisper
IoT.
at the server directly, it responds a little bit differently.
That's the trick.
Well, although actually you can utilize the metaphor, because when you whisper, because machine whisper stands actually for that you listen to what machines are telling you.
Right.
Now here comes the connection between the whispering and bare metal. An individual machine can't tell you much. The stuff what machines tell you only start to make sense when you do two things. Number one is you start to listen to all of them at the same time. And number two is you start to interpret what they tell you, because contrary to humans, machines talk to us in very simple code. Fault errors, temperature, pressure. They don't tell you much, but they tell you a few data points.
Yeah.
That starts to make an enormous amount of sense when they all start to talk to you at the same time in a certain context. Now, where comes the bare metal? If you want to listen to machines and interpret what they say to immediate intelligence at scale anywhere in the world, you can only productize that and run it at scale if you run at a cloud infrastructure, which means your network needs to run as software, which means that you need to accept the lowest level of automation and the highest level of compute and storage availability anywhere you want it to be, and then you gravitate towards bare metal.
And so you need that's kind of at the heart of what we're seeing with, I think things like NFC, right, and Open NFC, right, in terms of the virtualized compute, the virtualized storage, the virtualized networking to some extent,
Yeah.
is bare metal really a core requirement then?
Well, the way I like to think about it is, people have a lot of opinion about their application. These are high performance things, listening in crazy amount of fidelity and trying to act in real time to turn all this information into some sort of actionable event, right? In order to do that, you have to control your application to a high degree. So being able to put any type of application you want directly next to the network, that's why you have to have an infrastructure substrate, the lowest level, the most common denominator you can get. By the way, it's hard when you got to put these in lots of places. You might need to put it in different cities. You might need to put it within an actual enterprise, maybe in a factory floor. How are you going to guarantee to move an entire virtualized complex cloud to a factory floor?
Right.
You can't. So what you need to do is find the lowest common denominator. What that equals is bare metal. On top of that, what Ivo and their team have been able to do is create software to run their network so that they can push that anywhere. And they can run those applications from the IoT side, which is bringing all this data and expecting intelligence back. They can run that wherever it needs to go.
So go ahead, you're going to say something?
Well, actually, the one thing that I believe not a lot of people realize is that the software world and the network world, when it comes down to cellular networks, actually weren't that connected at all. The only place where the software application and the cellular network came together is actually somewhere in the cloud, in the internet.
Yeah.
Now, whilst that is good enough for consumer applications, when it's good enough for watching videos of YouTube and Netflix and what have you, if you're going to run mission critical workloads on that, you don't want to have the cellular network find the application somewhere in the cloud you don't control. You actually want that to find each other right at the edge where you want them to find each other, and to deploy that at scale, there is no other way to go than but bare metal, because otherwise it's going to be non-economical and it's going to be too limited.
I have another quote that I read about you too. I'm going to wait for the end of,
Oh, he's been doing his background
I'm gonna wait for the end of
on
the podcast because I want to talk about some other things first.
All right.
But it has to do with cows, and it might jog your memory a little bit.
Okay, cows.
Okay.
Oh, that's actually okay. I know.
Okay.
I think where you know you're going.
Okay.
You want to go there now, or?
Well, we
I
can't.
mean, I always think of it like DevOps. I mean, pets versus cattle, or how did you get to cows?
Well, okay. We'll get to it then right now, because I actually think this is actually illustrative of what you're talking about.
Okay.
And because you've had to build a software network, or you've had to build a network, and you've built the software into the network.
Yep.
True. What is the architecture of that network then? What have you built? What is it actually that you have built in this IoT network?
Okay, I'm going to be interested how you're going to revert this one to the cow, but we'll
Yeah,
get there.
yeah.
All right. Well, actually, what we've done is both very revolutionary and very common at the same time. Because what we have basically done is something very logic. When you think about what networks actually do, it's not that complicated. Networks connect a control plane and a user plane. The control plane basically controls the session so that whatever is talking to each other actually talks to each other. And the user plane is actually the actual data flow that goes. Now, in order to create that at a global scale and be able to route that, previously operators had a lot of boxes. We had antennas, and then you have a box to control the session, and another box to control the user plane, boxes everywhere, which basically means that you're
Very special boxes.
Yeah, very special
very
as well,
special.
very expensive as well. And actually what we have done is say, listen, if the whole world is moving to software, and what these boxes are doing is actually software anyway, because what runs on those boxes is software.
Right.
Why don't we just eradicate the need of any box in the network? So we have turned the entire network functionality 100%, not 80, not 90, no, 100% into software. And then we said, what does software run on most effectively? Bare metal. So you run your network software straight on bare metal, and suddenly, as long as we have 7 kilowatt of power, we can run an entire network. And then what we've done is, why do networks need to be closed? It's one of these things. Operators in the past built networks for operators. We should not build networks for operators. We should build networks for the users. Who are using the IoT networks? Applications. So why don't we allow an application to run at exactly the same infrastructure that powers the software of the network?
Otherwise, for instance, if you had lots of data sensors out there and you didn't have this network that you built, what would be the outcome of that? What would be the latency? What would be the issues that would come with using that older infrastructure for that purpose when you're using data sensors at scale?
So first of all, it'd be more expensive to connect every single data point that you get from a sensor to the application.
You have
So
to
it's just-
backhaul it all.
Exactly, backhaul all to one single place, which basically means that you need to route it to that one single place. You're actually bringing the data to the network. What we do, because we have more skill than the individual application, we're actually bringing the network to the data. So the second advantage that you then get is not only the higher economic value, but what you're also going to get is the immediacy, because we're basically reducing physical distance. And physical distance in the world of microseconds, actually, or milliseconds, actually matters. Yeah. So a round trip is 150 kilometers at light speed. If you actually bring it down to, let's say, 90 miles, which is 150 kilometers, then actually each 90 miles that you reduce is another millisecond one. But then the third one, and that's even bigger gain on the application performance, is it's not just the speed of the network points, it is the amount of hops in between. And we're actually complicating networks. It's like Uberizing the way you build networks, because you don't have to go first from the application to a box, from the one box to another box, from that box to a data center, from a breakout to the cloud, and then all the way back. No, the application sits right where the sensor connects. So you gain speed, lower cost, better application performance.
And so then the value add of bare metal is...
Well, I mean, what we're doing there is we have to move the application closer to this, to where the data is actually coming into the network, right? And right now, you've basically got wireless networks in particular, which take you from the end user through a radio, backhaul it to some central location. Oh, and then you got to find your application, which is usually not there, because carriers usually don't open their networks to other applications. So you got to go to some cloud, which is in someplace else. You've got all these interdependencies, latencies, changes, and you can't control it if you're the application owner. So what you get here is we're able to bring bare metal to the edge right next to where the wireless network is, bringing in those packets, bringing in that data. And the end user, the enterprise, can run their application directly next to the Curiosity core. That's really the power, is you're able to reduce that latency and ensure the path there. Suddenly you have guaranteed SLA, something for a critical application, something that actually matters, not just a YouTube download you're going to buffer, right? Which actually doesn't matter about these things because they've overcome it with pushing bits down the wire. This is where you can actually guarantee the application performance.
Actually, to make it super simple, one of the biggest applications we run inside of our networks is voice. And actually, meanwhile, when you digitize voice, you run VoLTE and so on. Actually, voice is an application, no longer a switched connection. Guess what applications we run on the edge of our networks? Voice. But what is because voice matters to operators. But so it's almost like mental blockage that we had. They said, well, hang on a second. Our IoT, our machines don't whisper to us in speech. They whisper to us in applications. So why do we allow as an operator to put voice at the edge of our network, but not actual applications? It's a simple. We were just wired wrong in the back of our minds. And it's the biggest compliment, I guess, to Zach and to all the folks coming up with bare metal and Curiosity and so on, is we see it happen now everywhere. So the best compliment is when you're being copied by the big boys.
The big boys.
And we're not that small ourselves.
Yeah. You announced, I think 2 weeks ago, a partnership that you're developing with Packet and Sprint's IoT network Curiosity.
Yep.
And you're starting in Detroit, and you were mentioning earlier you're going to be in other places too. Creating this, again, the Sprint IoT network with the Packet bare metal environment, also with Edge Connects. Mm-hmm. And maybe you could explain that relationship a little bit.
Sure.
But then I'm also curious of what is the implementation of that? And are you finding that the use cases are different by industry? And one of the things you see with cloud services, increasingly now with application development, you're starting to see some verticalization, but it's mostly been commoditized across any kind of environment. Continuous delivery tools are used, in multiple different markets, right? You can say that for a lot of software overall. So what's the difference here? That you're seeing with an implementation of this type of architecture
on bare metal.
Well, maybe I'll handle the Detroit thing, and then you can cover
go
what
ahead.
you're seeing with the industries, because the customers, I think, are driving that, right? So what we're doing is, and this is not the first time we've done this, we've been taking Curiosity into lots of places,
Right.
Wherever the customer wants it to go.
Yeah.
Ivo and our teams here at Packet work together to bring a bare metal compute location and the Curiosity application and network to that place, right? So we're doing it in Detroit. Why it's notable is not only were we able to go there for some specific customers and use cases that I think are quite relevant and interesting. I think it's the first time cloud's in Detroit. And now what we've done is connected a wireless network, a cutting edge IoT platform, the 5G network that's coming with it, and I think it's the first cloud that's actually available in Detroit.
And it's fascinating. People don't realize that. I mean, because you can access the cloud in Detroit. You could do that a long time ago, but that's because you've got internet access in Detroit. But one of the things that people don't realize, people think that the cloud is distributed. Actually, it's not. The cloud is hyper centralized with massive data centers in a few places.
Right.
But there was no cloud instance in Detroit. And the fact that it was picked up, that now there is cloud infrastructure in Detroit, was actually quite interesting. But for us, the new thing is, because we kind of did two things for the first time. First, bringing the cloud actually to Detroit. But the second thing is, we are also now running the Curiosity network out of a public data center. And the public data center, because that's also a new thing for an operator. Typically, you would run your networks out of your own data centers. That's the old thinking, because this bare metal works just as good, if not better, in a public data center. Why would it work better in a public data center? Not because it's easier for the operator to put all their stuff there, although it is, but it's because it's very easy for our customers to put their applications right next to it. Again, simplifying the whole production model of the connected application. And to just tell you, because when we go to a city, it's very often because a customer asks us to be there. In this case, it was Accenture, because Accenture is opening a massive innovation center. And because they are opening an innovation center, they want Curiosity to be part of that innovation center, because there is a big concentration of entrepreneurial companies that want to explore IoT capabilities. So they needed a Curiosity node to be able to demonstrate that to customers right there.
Do you find then that you'll have a different type of software pattern in terms of development in that kind of environment than you do with hyper-converged data center environments, such as what the major cloud services provide?
Yes, for two reasons. First of all, the application will behave better when both the application and the network run in the same place. That's just physics. The second thing is, today it's very difficult for a developer to build a connected product in a live commercial network. The reason is more historic than anything, is that operators don't really allow applications in their networks that are run by others. And therefore, a developer, when they want to try and develop an application, for them it's more or less developing the application, running it on a connected product, and then once it's ready, they go to an operator and they need to go through all kinds of certification to see if it actually works and how it behaves. Guess what? Most connected products are not developed on top of cellular networks because it's much easier to do it on Wi-Fi or Bluetooth. Hence why we're standing a little bit too much in our own way. And that's another barrier we're breaking through.
I think that's a super good point, because we take that for granted coming from the cloud, that you actually can real-time develop, deploy, continuous CI, continuous deployment, test your application in the place that you're going to run it in production. You can't do that in the cellular world. You don't get access to run it within the cellular network until you've kind of built everything, and then you go deploy it out in the field and then ask an operator for access.
It's kind of weird. It's like developing a car and then bring it into massive production and then test it out on the road for the first time. You would want to develop the car whilst putting it on the road and being able to test it, and then when you're finally done, then you put it on the road, but not for the first time. Although that's how cellular-enabled IoT applications were developed in the past, no longer.
How will they be developed in the future? I'm curious, too, how you view your own work in developing a software platform for your IoT environment and how that is influencing your perspectives on software development itself.
Well, first of all, we're not under any illusions that we can develop those applications better than anyone
But you've
else.
had to find ways to monitor your own network.
Of course. So, first of all, we're using this to our own benefit in a strong partnership with Ericsson, who've done a really good job in turning the network software into software. They are now utilizing the Curiosity platform for two things. First of all, learning themselves how they can optimize their network software in a distributed environment. Second of all, the Curiosity architecture, because it's software, doesn't know any boundaries. So we're now sitting down together with Ericsson and with Packet to think, how can we utilize this architecture to expand the availability of Curiosity globally, not just internationally, global, because you need to think like software. Software is global. So that's another thing. In the end, it also opens us opportunities to work together with very advanced environments, sometimes in the entrepreneurial world, but also in the academic world. We've recently signed a partnership that I'm really proud of. Packet is part of it. We're part of it together with State University of Arizona, ASU, one of the most digital universities in the USA, who will deploy this mobile sandbox, the Curiosity platform, on site to basically allow their R&D and research to research on a live commercial network. So basically, we're making them smarter. They, however, are also going to make us smarter because they're going to stand up a curriculum to start to learn what if application, bare metal, and cellular networks are no longer three things. How does that work? How can you do edge development? So they're going to teach us that. And then together, we're going to roll out these technologies across Arizona.
I would think that this must be a hurdle too, because in listening to you, the language that you use is much different than the language that I hear from developers or people who are developing database platforms for cloud services, for example. And in those environments, I'll talk to them about Git. I'll talk to them about continuous development. I'll talk to them about.
We have a long ways to go on this. I mean, one of the things I think is so interesting about what Ivo's done with ASU and what ASU is creating in their R&D side is you have to empower a whole new class of developers. I mean, this is something that they just don't have the language around connectivity, around IoT devices. It's a lot to bring in. You've got cellular connectivity, you've got IoT endpoints, which are physical, you've got applications, you've got cloud infrastructure. You put that all together, it's a pretty complex stack. This is very different than run my application, get access to the internet. Right?
Yeah.
So we have to educate people on all these different components just so they can innovate. These are people who are very smart on the application side, but might not know anything about IoT. Or vice versa, IoT people don't know anything about developing cloud-based distributed applications.
There was a bit of the epiphany moment when we had sitting down together with ASU. We said, listen, you can teach somebody to become a coder. You can teach somebody to be a data scientist. You can teach somebody to know something about radio networks. You can teach people how to build a physical network. But who is actually thinking horizontally how to build an application that utilizes connectivity and runs at the edge and actually utilizes AI in a way to change the world? That doesn't exist yet today. So we decided to create it.
You know what's, Alex, one of the things that I think is happening right now by the work we're doing at Curiosity and just putting wireless and cloud together, right? Very similar to the early days of the cloud. I got started in this business in 2001 where you had to go to your IT administrator to get access to a server to run your application. Well, the rate and pace of software development was a lot slower. You saw a lot more control with a few software vendors to basically be able to push and deploy and put code into a production data center in your Sun Microsystems, big consolidated rack that was gated by a bunch of sysadmins. And then suddenly in 2006, I think we're in the shadow of reInvent. The bookseller comes out and says, hey, anybody can sign up and use this API and get access to the data center. And then within a few years, we had millions of people deploying applications, innovating, this continuous deployment, this distributed app stack, all these new technologies came about because you gave developers access, which before wasn't available. And if you look at today in terms of economics, the world of wireless, which I don't know what you do all day, but when I walk around Manhattan, most people are sitting there staring at a wireless device or interacting with a wireless device or having a wireless device on their watch. Or my kids don't know what a wired device is like. So you spend the vast majority of your world now surrounded by wireless, but only a few software companies get to innovate on that. And the pace is very slow. The integration time, I mean, this, Ivo's been within carriers. What's the standard software integration time in a carrier network? I don't know.
Oof. If it touches the billing system, it's once a year.
So this is a long, slow process.
So how does 5G influence this? How will 5G be the influencer in this development? Booksellers were actually the book readers, right?
Yeah.
And so how does 5G kind of bring that developer ethos into this world, and how does it change your vision of your own IoT network overall and bare metal itself?
Okay, so there's one thing first that is technical, and then there's the other one, which is I like to think of as more of a social impact. So first of all, the technical thing is relatively simple. 5G is going to make speeds go so fast with such a low latency that the wireless network, which in effect is just basically a ramp onto the highway, and the highway actually is the long haul, is the backhaul, it's the fiber, it's where the applications are. And again, operators need to be conscious of the fact that we're basically developing a wireless local loop onto the platform that actually creates the intelligence. Now, when the ramp onto that highway now becomes so fast that actually you can have an application react in milliseconds, a whole lot of new opportunities are starting to happen. But this is just a technical way that a wireless network that is so reliable and so fast that it behaves like a wireline network actually will give a much lower entry barrier of high-end applications performing tactile, immediate reactions. That's purely technical. The social part is that when an application starts to behave with a response time that is below the human response time, you're starting to cross the line between virtual and reality, and things start to become much more intuitive. Not a lot of people, unless you've experienced it, have actually seen what it means to have a tactile internet that reads like a book, that there is no more delay. And actually it will allow us to actually stop teaching technology to people and start teaching people to technology. And actually the interaction with, whether it's a robot, whether it is a translation, you and I could be talking two different languages right now and we wouldn't even notice anymore. These are things that have profound social impact on the fact that the actual barrier between machine and human will start to become more and more blurred.
Well,
how about that for starting?
How about that? So I'm going to finish this with the quote.
Wait, can I answer with one thing first?
Of course you can.
I've come in from the cloud side here, and I think that there's something really beautiful about 5G for timing, okay? Because Dan Kahn gave a really fascinating speech earlier today. Incredible presentation, Minecraft. Second graders,
kids staring
at it, like enterprises or second graders. I don't know. It was just awesome, and he did it with such. He must have practiced that in his bedroom like 100 times to go that fast. But one of the things that he was pointing out, he went back in history and he said it's almost like ideas pulled themselves out of thin air. Why did these people invent the same thing at the same time?
Right.
And part of that has to do with that there was this kind of critical mass of the knowledge available, or the capabilities available to light that spark with multiple. It didn't just happen for one person. And so what I think is really fascinating is 5G is a network being built in 2020. Right? This is technology that's getting deployed in an entirely new decade. You go back to the last time networks went out and deployed at scale, a brand new thing. This is LTE, right? I mean, what was the deploy time of LTE? Probably 2007, 8 was the right? I mean, we barely started to understand how we would use cloud.
But it's such an interesting way to look at it backwards. What you see in hindsight, what 4G created. 4G created the Ubers of this world, the Netflix at scale, the turned basically the smartphone in the mosquitoes of mankind. But okay,
messaging.
It's not always. I mean, messaging. And do you think we had that in mind when 4G was rolled out? No way. So why do people think that we actually know what 5G is going to do for us? No idea. But it will be good.
So what I think is the confluence of things that is coming out of Air is that there's enough there's millions of developers that know how to write software for cloud.
Right.
There's also this really advanced disaggregated infrastructure. What Ivo's doing with Curiosity and Ericsson to disaggregate the network from hardware wasn't in the air 10 years ago. It is now in the air.
It's popping up in multiple places.
Exactly. It's not like people are doing this, right? Like Rakuten's doing it now in Japan. They're saying, oh, wait, I could build my network with software.
Yeah.
And so now lots of people around the world are kind of coming to this conclusion because the capability set is now available.
The bizarre thing is, it's always been there. It's probably been there thousands of years. But now we've gotten to this point where we can actually discover it.
Well, I'm not sure we could build 5G networks thousands of years ago.
No, but we built 5G networks today.
Right.
But that capability was there at some point. It's always... It was a philosophical question more than anything else.
There's some pretty incredible technology has been invented, but this disaggregation is really creating a new thing. Like you can run this whole network investment as software, and developers are going to write applications and put them places without asking IT administrators. Is kind of like pretty well accepted now. And to be able to have this disaggregated infrastructure that's powering these innovative new networks like 5G naturally allows people to run applications there.
Yeah.
I mean, it's kind of like, oh, well, now I can do that.
And coming back to what you said earlier, why are sometimes ideas all coming in different places in the world all at the same time? Is I believe that intuitively it was there, but there is a moment in time, probably defined by context or whatever it is, that people start to trust their intuition. And only when you start to trust your intuition, you dare turning it into reality. And that happens at the same places several times, and suddenly it is the new reality.
And that's the thing.
And now it is.
And what about the cows?
So speaking of all these things, this is a quote that I read from a story that you were quoted in, Ivo. You said, our global IoT platform allows Moocall to remotely manage and monitor every one of its sensors used by farmers, whether they are in the UK or in Australia. Together with Moocall, we are pleased to provide how the Internet of Things can help save the lives of calves.
27,000 cows a year. And it's because honestly, I like to talk much more what IoT can do for people, for animals, for society, rather than the technology enabling it. But it's relatively simple. When you are a farmer and you have many cows, unfortunately, it's a disadvantage of domesticating animals is that cows over time have lost the ability, mind you, to deliver a calf autonomously themselves. And actually there's a high mortality rate of cows being delivered. So humans need to intervene. But a cow is not going to call you and say, I'm about to deliver. So, and by the way,
bad mood.
And therefore, actually, when you have hundreds of cows, at any moment in time, there's multiple of them, they're pregnant. And actually what Moocall has developed is an application that runs on the back of a sensor that is attached to the tail of a pregnant cow that actually anticipate when the cow goes into labor about half an hour before it actually happens, which basically means the farmer is woken up, the labor doesn't start until they're there, well, it doesn't wait for it, but they're there in time, and when they intervene in time and they can help deliver the cow, the mortality rate of cows has gone significantly down. But I tell you, that was an anecdote. It's not an anecdote, it's a real life situation from about 5 years ago. Fast forward now, you know what we've monitored on a daily basis? 4 billion heartbeats. That's the equivalent of about 40,000 people with a heart condition. In the old world, which was reactive, these people with a heart condition would have a monitor and there would be an alarm and they would go into cardiac arrest. And we would, not we, but the solution provider would arrive barely in time or just too late, but at least they gained some time. Today, Fast forward, with AI, they can actually predict a cardiac arrest 4 minutes before it's there. Now that's 4 minutes that save lives.
Well, I've really enjoyed this conversation. Thank you so much for taking some time here at IFX, and hats off to Packet and your team for putting on a great conference. And it's really been interesting to hear your perspectives, Ivo, from a sprint perspective and your own philosophical and technical viewpoints. And so
It's not every day you get to talk to the machine whisperer.
yeah. So I was just going to say on that note, have a great show, and hope you enjoy the holidays with your little ones and
I will.
your family. And thank you very much for your
Well,
time.
thanks, Alex.
Okay,
It's been
thank
fun.
you so much.
Yeah.
All right,
Thanks,
cheers.
Alex.
Yes. Thanks.
Cheers, buddy.